Less than 70,000 years ago, it was a land of monsters. The top predator was the giant lizard called Megalania, a 6-meter-long mega-monster known as the Giant Ripper. But the biggest beast in the bush was Diprotodon, a plant-eating mammal the size of a rhinoceros.
We're looking at the world's largest marsupial ever, an absolute monster. Now, an animal like that has no natural predators.
Diprotodon probably wasn't a very nice animal. It was mean, and it was large, and it would be something that all animals, I think, would avoid.
At 2,700 kilograms, Diprotodon outweighed Megalania 10 to 1. The killer lizard have brought down this walking mountain of meat.
Megalania would have found adult Diprotodons inherently difficult to tackle. The sheer size of Diprotodon in and of itself would have been a very effective defense against predators, including Megalania.
But evidence is growing that Megalania had a secret weapon that would have allowed it to tackle literally anything, including these giant marsupials. Once again, the living monitor lizard offers clues to the past. The Komodo dragon regularly hunts animals far larger than itself. It has been known to kill water buffalo 10 times its own weight. It's long been thought that the Komodo dragon has a sort of deadly drool full of infectious bacteria that lives on rotting meat in its gums. But Brian Fry believes it is a myth.
The problem with the toxic bacteria theory was that it's based entirely on an absence of evidence. There's no evidence for this. The one study that looked at the bacteria found pretty much the same bog standard bacteria you'd find in the mouth of a kindergartner, a lion, or in the intestinal tract of one of their prey items. There's nothing unique in there. There's no super toxic bacteria.
Brian Fry thought there might be another explanation for the Komodo's deadly bite.
The first thing we noticed when we started working with these animals is a huge bulge running the length of the lower jaw on either side. But if you go into the reptile anatomy books, it's not in there. There's nothing in the anatomy books talking about that, even though this is a massive bulge. This is not a trivial structure. And that got me thinking immediately, because this is the exact same location where you find the venom gland of the American Gila monster or the Mexican beaded lizard, thought to be the only venomous lizards in the world. But they're also very close relatives of the monitor lizards. So it was not inconceivable that this bulge was the same gland as the Gila monster, and therefore they may be producing the same venom.
Eventually, Fry found a way to prove his theory, using the preserved head of a very rare Komodo dragon.
What I have here is a real Komodo dragon head. This is a zoo animal that was captive bred that died, that we were then allowed the opportunity to use for our research.
Fry and his team scanned the head using MRI technology.
With the magnetic resonance imaging technology, we're able to go from a preserved head like this into computer data where we now have everything rendered in 3 dimensions. And what that means is that we can examine what's happening on the inside. So here we have the 2 eyes. The gray is the tongue there, the long tongue that you see coming out. And then we have showing here 2 sets of glands on either side.
The lower set of glands on each side produces venom. Fry has discovered that the Komodo dragon isn't the only monitor lizard with this type of venom gland.
Looked at monitor lizards now from everywhere where they occur. Africa, Asia, and Australia. We've also looked at all different kinds of species, whether it be the ones that live in the trees, the ones on the ground, and even the aquatic ones. They all have the same generalized gland, and they all have very similar venom.
Snakes have powerful muscles specifically for injecting their venom through hypodermic-like fangs. Monitor lizards, however, don't have the ability to inject their poison. Instead, they rely on a different method. When the Komodo bites its prey, the pressure forces venom from the glands into its mouth where it mixes with saliva. The toxic brew then oozes into the wound. If modern monitor lizards have venom glands, is it likely that Megalania also would have the ability to produce toxins?
Megalania was basically just a supercharged lace monitor. That would be the closest relative of it. Now, the closest relative of the lace monitor is the Komodo dragon. And we've studied the venom in both the lace monitor and the Komodo dragon. So if you have an animal with very similar anatomical features, it should logically possess the same venom glands. All of this strongly suggests that Megalania was the largest venomous animal to have ever lived.
If Fry is correct, this venom gland might have been the secret weapon that gave Megalania the power to bring down huge prey animals and even compete with other predators. No matter how it killed, for hundreds of thousands of years, Megalania was the undisputed mega-monster of its world. But around 50,000 years ago, a new predator arrived on the scene. The first humans to arrive on the continent found that Australia was a hunter's jackpot. The land that Aussies called the Lucky Country teemed with an endless bounty of edible beasts. But those early Australians may not have been the only predators after the abundant prey. Megalania, the giant ripper, had dominated the land. Did those early human beings ever cross paths with this monster lizard? Most scientists believe humans migrated to Australia from Asia or Africa around 50,000 years ago. Is it likely that Megalania was still alive at this time? To answer this question, we must determine the age of the youngest Megalania fossils. Until now, there was no way to do this with any degree of certainty. The well-known carbon-14 dating method can only be used on fossils up to 40,000 years old, much later than the arrival of the first humans. But this machine allows us to extend our ability to date fossils much further into the past. It's called the TIMS, the Thermal Ionization Mass Spectrometer.
Now that allows us to push the dating limit back to somewhere between 500 and 600,000 years. So, long way outside of that radiocarbon dating barrier.
Dr. Price ran 10 samples taken from Megalania teeth through the TIMS. Price is still reviewing his findings, but the preliminary results indicate that Megalania may well have been alive 50,000 years ago, around the time humans arrived on the continent.
We've got some exciting new data that's starting to come out, based not only on direct fossil evidence, but also on the dating as well. And it's starting to suggest that we do have a time overlap between the last of the megafauna, specifically animals like Megalania, and some of the first human colonizers that entered Australia.
If this is true, Dr. Price's research could rewrite the history of prehistoric Australia. If humans and Megalania did live in Australia at the same time, they could have encountered each other. What then? How effective would the primitive weapons of the first Australians have been against a venomous giant lizard 6 meters long?
This is a fire-hardened tip on the end of a spear. This is the sort of spear that people would have used in the Pleistocene. This, in fact, is made out of mulga. It's heavy. It's very strong. It would be very difficult to break. And it's the sort of spear that's needed for thrusting. And you'd have people either side jabbing with similar weapons to distract it. But even with all this happening, this is not really a weapon that would really help you against Megalania.
Running from megalania wasn't an option either. Like all monitor lizards, this creature was remarkably fast.
The speed with which Komodo dragons can run, for example, they can run up a hill faster than I can run down it. A 100-pound human being would not have stood a chance against a 20-foot-long megalania or even a 12-foot-long megalania. It would have been lunch.
Megalania was Australia's alpha predator for at least 500,000 years.
A big megalania would have no natural predators. There would have been nothing alive at that point in time that could have taken it out.
Yet this giant lizard, which had ruled a continent, eventually died out. It disappeared, leaving only a few fossilized bones to mark its legacy. How could such a megabeast vanish without a trace?
Many people think that extinction is an instant process, something that occurs overnight. But extinction is a very complicated process, and it usually happens over thousands and thousands of years.
We don't know why megalania became extinct. It could have been because of climate change, or it could be because of human hunting, or perhaps a combination of both. The fact is, all the megafauna in Australia became extinct, megalania amongst them.
Despite the occasional rumors that megalania is still lurking in the Australian outback, paleontologists have no doubt that the giant lizard is long gone. It would seem that the age-old rivalry between reptiles and mammals has been settled. But there are still plenty of megalania's relatives alive today. A monstrous Komodo dragon can reach a length of 3 meters and has been known to kill people. Humans have been around for about 200,000 years, but monitor lizards have survived for 60 million years. There's no question that these cold-blooded killers are quite capable of making a comeback.
If humans were to go extinct, it's pretty easy to imagine that a giant monitor lizard would again evolve from in the Australian environment. All it would need is for the top predator, the humans, to go away, and they'd be back as dominant predators. Same size as megalania, maybe bigger.
Lizards would think of things